Right now, above your head, there is a sky you will never fully see. Not because it's too dark, because it's too big, and it's running away from you. The universe is so large that light itself, the fastest thing that exists, cannot keep up with it. In the next few minutes, we're going to zoom out, step by step, away from your room, your city, your planet, until the Earth disappears, the sun disappears, our entire galaxy becomes a single point of light, and then vanishes too. And by the end, I'll show you something that sounds impossible, that most of the universe you can see tonight is already gone, lost to us forever. This is how big the universe really is. Hold on. Let's start with something you can picture. Home. Earth, 8,000 miles across, big enough that we've never walked all of it. Now zoom out. Our whole planet becomes a blue dot next to the sun, a star so wide 1,000,000 Earths would fit inside it. And the sun is not alone. It drags 8 planets behind it, out to Neptune, and past that, a frozen shell of comets, our solar system. Light crosses your bedroom instantly, but to cross the solar system, that same light takes hours. We launched a spacecraft, Voyager, in 1977. It has flown for over 45 years, at 40,000 miles an hour, without stopping. And it has still barely left our own doorstep, because the nearest thing beyond us is almost unimaginably far. Here's where your brain starts to break. The distances stop making sense. So we stop using miles. We use how far light travels in a year. A light year. Nearly 6 trillion miles. The nearest star to the sun is Proxima Centauri. It is 4.2 light years away. Picture the sun shrunk to the size of a single grain of sand. On that scale, the next grain of sand, the next star, is 10 miles away. 10 miles of total, empty, absolute darkness for 2 grains of sand. That is what space actually is. Not stars. Emptiness. Almost incomprehensibly vast, cold, and silent nothing, with the rarest scattering of light. And we are about to fill the sky with hundreds of billions of those points of light. This is our galaxy, the Milky Way, a slowly turning wheel of somewhere between 100 and 400 billion stars, bound together by gravity. It is 100,000 light years across, which means light, the fastest thing there is, needs 100,000 years just to cross the galaxy we live in. Our sun is out here. Not the center, not special, just one star on one arm, a little more than halfway out. It takes our sun 230 million years to travel once around the galaxy. The last time we were on this side, dinosaurs had not yet appeared. And at the very center, holding it all together, is a black hole 4 million times the mass of the sun. Now, hold this entire galaxy in your mind, all 400 billion suns, because I'm about to turn it into a single dot. Zoom out again, until the whole Milky Way is just a faint smudge of light. Because it has neighbors. The nearest large one is Andromeda, another spiral, even bigger than ours, with 1 trillion stars. It is 2.5 million light years away. The light you'd see from it left before human beings existed. And it is falling toward us. In about 4 billion years, Andromeda and the Milky Way will collide and tear through each other and slowly merge into one. Our 2 galaxies, and a few dozen smaller ones, are bound together in what we call the local group. But the local group is nothing, a village. Because zoom out one more time, and even galaxies start to look like grains of dust. This is the largest structure that exists, the cosmic web. Galaxies are not scattered randomly. Gravity has pulled them into vast glowing filaments, threads of thousands of galaxies wrapped around enormous empty voids. Our local group sits on the edge of one such thread, being pulled toward a gravitational something we've named the Great Attractor. Cluster upon cluster, supercluster upon supercluster. Our home address is a galaxy, in a group, in a supercluster called Laniakea, a Hawaiian word meaning immeasurable heaven. From far enough away, every galaxy you have ever heard of becomes a single point of light in a web that stretches on and on and on. So how far does it go? How big is the whole thing? This is where the real answer lives, and it's stranger than you think. We can only see a part of the universe, the part whose light has had time to reach us. We call it the Observable Universe. Inside it, there are an estimated 2 trillion galaxies. Not 2 trillion stars, 2 trillion galaxies, each with billions of stars of its own. The universe is 13.8 billion years old, so you'd think we could see 13.8 billion light years in every direction. But we can see farther, much farther. Because while that light was traveling, space itself was stretching, carrying those galaxies away. The observable universe is 93 billion light years across, a number so large it has no meaning to a human mind. And here is the part that should stop you cold. That is only the part we can see. Everything is moving apart, not because galaxies are flying through space, but because space itself is expanding, everywhere, all at once. 2 galaxies sitting still will still drift apart as new space appears between them. And the farther away a galaxy is, the faster that space grows, until, past a certain distance, galaxies are receding from us faster than the speed of light. Light leaving them can never close the gap. It is like running up a stairway that grows faster than you can climb. There is a horizon out there, a distance beyond which we can never see and never reach, no matter how long we wait or how fast we travel. The universe has an edge for us, not the edge of everything, the edge of everything we are allowed to know. And now the promise I made at the start. Most of the galaxies you can see in a deep image of the night sky, we can never reach. Ever. Even at the speed of light, we could set out today and they would race away faster than we could follow. It gets lonelier. As the universe keeps expanding, more and more galaxies cross that horizon and disappear from view. For good. In the far, far future, the sky will empty. A civilization then will look up and see only their own galaxy, surrounded by perfect black, and conclude the universe is small and still and alone. The light is still arriving from galaxies that, right now, are already gone, pulled beyond the edge while their old light finishes its journey to your eye. You are looking at ghosts. So, how big is the universe? The honest answer is, we don't know. The observable universe is 93 billion light years across, but the universe itself is larger, possibly far larger, possibly infinite. Everything past our horizon is forever hidden. There could be 100 times more. There could be no end at all. Somewhere out there, past everything we can ever see, there may be other galaxies, other worlds, other skies that no one here will ever know existed. We are sealed inside a bubble of light, in a cosmos that dwarfs it beyond all meaning. Which raises one last question. If we are this small, why does any of it matter? Here is why. In all of that, the 2 trillion galaxies, the 93 billion light years, the endless expanding dark, there is one thing we have never found anywhere else. Something that looks up. Something that measures the distance to the edge and feels small and keeps looking anyway. The universe is almost entirely empty and cold and indifferent. But on one pale blue rock, it grew eyes. It became aware of itself. You are the part of the universe that gets to wonder how big it is. If that made the sky feel a little bigger tonight, subscribe, drop a like, and comment how far you think it really goes. There's a whole universe left to explore, and we're only just getting started.